Hello, my name is Alex Carter, and today I'm going to be talking about what thermal infrared or IR light is. The first thing you need to know is the actual structure of light. So we're going to start off with what is a wavelength. A wavelength is the distance between 2 points on consecutive waves of light. Now, light travels in waves, so this helps us determine what the color and what the energy is of that light. The next thing is amplitude, which is the distance between that line down the middle of your wavelength and either the top or the bottom. So here to here on your wavelength. And then finally, frequency. And frequency is just how fast those squiggles of light are going past you. So now we're going to talk about the electromagnetic spectrum. Light is a spectrum. It is not necessarily unique values. So what the human eye can see is visible light, which is this area in the green box. Visible light is anything that the human can see. The screen, my laptop, the table, this is all emitting in visible light. Today, what we're going to focus on is thermal light, which is a longer wavelength and lower energy than visible light, and is in this red box over here. So this is something maybe your heater gives off in thermal. And really the thing to know is most, if not everything, gives off in thermal unless it has no temperature at all. And the human eye just can't see it, but it is still there. And we're going to talk about a camera that actually can look in that part of the spectrum and display it for us. So a little bit of history. Thermal cameras were originally used for the military during the Korean War. They were used to pick up on tanks, humans, landmines, anything that has a temperature difference from the area around it that someone in the military might care to see. You don't really want to go wandering around and just sort of walk into a tank. Here you can see that the wheels are hotter than the area around it. Here, so they show up as brighter. Modern day uses include use in low visibility situations. So firemen use them because they might walk into a very smoky room and not be able to see through the smoke. Humans can't see through smoke that's thick. Our eyes don't allow it. Visible light doesn't get through. However, infrared does get through because infrared is temperature. So we can actually see, as in this image on the left, that there is a human on the ground because the human is much warmer than the area around it, and the thermal camera can pick up on that. You can also see that the fireman is warmer. Another use is in sort of like a night vision versus thermal vision situation. Night vision allows you to basically see in the dark. You can pick up edges, foliage, but you can't see through things necessarily. Whereas with thermal, in this image you can see that it's the same area, but the thermal is the one on the right, and you can see the human through the foliage because they are at a different temperature and giving off light that has more energy, is stronger than on the left, where you can not see the human at all. You can also use thermal cameras to look at buildings or any other physical structure. You can see temperature differences. So in this one, you can see that because heat rises, you can see that the roof is actually much hotter than perhaps the walls. And that's just because it's been heated up and is giving off more temperature, more thermal energy than the walls. Similarly with volcanoes, you might want to see how active a volcano is, but you don't necessarily want to get up close to it. So here you can see before and after an eruption. On the left, you see visible, so what the human eye can see. And on the right, you can use a thermal camera to look, and you can see that there is geologic activity, perhaps a lava flow or hot gas. Either way, it's significantly warmer. And down below, it's after the eruption, where you can see that that activity has changed and the structure of the mountain itself has changed. Another use, which I just find entertaining, is you can pick up on human farts. The reason for this is simply because human farts are at a different temperature than the air around them. So while the atmosphere might be a nice room temperature, the human fart will be significantly hotter. And you can use this for other cases too. You can basically pick up on any gas that is a different temperature than the gas around it. But you might not be able to tell the difference just looking at it. So you can also use this to look at animals, in this case a dog. You can see that the dog's nose is much cooler here than its eyes, its ears. This is mostly because of blood flow, and blood warms up the skin around it, making it change temperature. You can see that where there's fur on the dog, so its face, its paws, its back, all read as cooler than the rest of the dog. This does not mean that the dog itself is colder. This means that the fur is acting as an insulating layer and is actually keeping the dog's body heat on the dog like it's supposed to. And because thermal cameras only look at the surface of something, they're not X-ray vision, it's reading the temperature of the fur, not the temperature of the skin underneath the fur. Now you can look at something that's cold-blooded, like a snake or a lizard, which regulate their temperature differently than mammals. This is a particular image of a snake on a human hand. So you can see that the hand is much warmer than the snake. But if the snake stays there long enough, because of the way that snake biology works, its temperature will start to change to closer match that of the hand holding it. So somewhere in this region, you can actually see that the body of the snake is warming up. And this temperature difference can easily be detected by a thermal IR camera. Finally, we're going to talk about blood flow in human hands and really the human body. The hand on the left is much colder than the hand on the right. I would probably be a little concerned for their health. That seems to be very cold. That's in the, if you look at the bar on the right, that's in the 25 C range, or 25 Celsius. Whereas the hand on the right is much warmer, probably much closer to the rest of the human's temperature. This is just because of blood flow. You can see that there are blood vessels here. Blood warms up the area around it, making it read as much hotter. So now that we've gone through some of the uses of thermal IR cameras, where we actually have one here to play with today, and I'm going to show you some of the limitations and cool uses for it. So one of the things that you can do is you can actually reflect light off of a shiny surface, which I'll show you in a moment with the whiteboard behind me. But I will emphasize that this does only detect heat. This is not X-ray vision. This does not see behind surfaces. If you have one surface and something behind it, you're not going to see it unless that item is hot enough to heat up the surface that you are measuring. Then you can actually see that temperature change on the surface you're pointed at. You're also limited by water in the atmosphere because of the way that light works. When you point at something, if there's a lot of water between, the light can't really get through it as well. Let's play with the camera, my favorite part. So, just gonna connect over here. So immediately, we can actually see the TV screen in the back of the room. And if I point down, it's kind of cool, you can see the reflection. In reality, there's nothing physically there, but we are seeing the reflected light from the TV off of the table and into the camera. That's a fun trick. I'm going to pan the camera over a little. I'm currently pointed at a visibly clear piece of plastic. You cannot see through this. The light cannot get through this plastic, even though you can see it invisible. Now, cool trick, there's actually someone behind it. Say hi, Hillary. That's Hillary. She's been behind the screen the whole time. Can't see her behind it? You can see her in front of it. Now we're going to talk about how temperature goes through surfaces. Right now, I am pointed at a roll of paper towels. A little bit of focus on that. And what I'm going to do is show how you can measure through surfaces, or you can measure heat that is transferred through surfaces. So because my hand is so much warmer than the paper towels, I'm just going to use it to heat it up. Once we have that done, all right, see my handprint on top. Take my hand away, my handprint on the surface of the paper towel. I'm just going to unroll it. My handprint still there. A few layers in, still have a handprint. This is because the heat from my hand went through not just the first surface of the paper towel, but into the second, the third, even deeper. And eventually you'll see my handprint get smaller as it cools, as we go farther in. Less heat went into the paper towels, so you're picking up less heat as you go along. Some other fun things, if we point a little farther over there, you can see the lid of my water bottle, which is very cold compared to the area around it. You can actually see my phone, which is the hot spot next to it. That is an electronic device, so it's giving off more heat. Finally, I promised we would look at reflections. So we'll spin around, point at the whiteboard, and you can see my reflection in the whiteboard. You can also see the computer screen behind me. And this is just reflection of the heat coming from my body off the whiteboard and back to the camera that the camera is actually able to pick up on. So these are just some fun, cool uses for a thermal camera that you can do with everyday items. There are more professional uses, but we like to have fun here. So I hope you learned a lot today. That was just a brief interview to Thermal IR. Have a good one.